Hello friends, continuing with chapter Physical World. Today we take up second topic, physics and its scope. In the first topic we have dealt with scientific method, and we have seen how scientific method helps us in acquiring systematic knowledge, and the steps involved had been observations, logical reasoning, model making or experimentation, and theoretical predictions. Now we come to physics. What is physics? First question that comes to our mind, what is physics? Physics is the branch of science which deals with the study of nature and natural phenomena. Physics is the branch of science which deals with the study of nature and natural phenomena. It is associated with space, time, motion, matter, energy, and radiation. So these are the 6 words that are very important to physics, field of physics. So we can say almost these are the fields of physics. Okay. Now we come to another question. What are two principal thrusts of physics? The two principal thrusts of physics are unification and reductionism. We take up one by one. First we take up unification. Unification is attempting to explain diverse physical phenomena in terms of few concepts and laws. What is unification? Unification is attempting to explain diverse physical phenomena in terms of few concepts and laws. For example, law of gravitation given by Newton accounts for number 1, fall of an apple to ground, number 2, motion of satellites around Earth, number 3, motion of planets around Sun. You see, all these three phenomena are governed by a single law of gravitation. So this is how unification works. Unification is attempting to explain diverse physical phenomena in terms of few concepts and laws. The single law explains three different diverse phenomena. So we can say it is unification of physics. So physics first thrust is on unification. Now second is reductionism. So what is reductionism? Let us see. Reductionism is attempting to derive the properties of a bigger, more complex systems from the properties of its constituent simpler parts. What is reductionism? Reductionism is attempting to derive the properties of a bigger, more complex systems from the properties of its constituent simpler parts. For example, thermodynamics. Thermodynamics deals with bulk systems in terms of macroscopic quantities like temperature, internal energy, and entropy. Number 2, kinetic theory and statistical mechanics interpreted these quantities in terms of the molecular constituents of the bulk systems. That is, temperature of the bulk system was related to average kinetic energy of the molecules of the system, as average kinetic energy is equal to RT. So this is how reductionism functions. For example, when you go to market, you want to purchase a bag of 1 quintal of rice. So bag is sealed. What you do? You take out some sample, and then you decide about the whole bag, what quality of it would be. Similarly, here we have reductionism. That is, reductionism is attempting to derive the properties of a bigger, more complex systems from the properties of its constituent simpler parts. Okay. Now we come to difference between science and technology. How we can differentiate between science and technology? I have tabulated some matter here. Just see, first is serial number with have second column has science, third column has technology. So under the column you can see first we take up definition. Now science, what is science? Definition of science, we say systematic knowledge acquired through scientific method. Systematic knowledge acquired through scientific method is defined as science, and applications of science is defined as technology. Now we go to second point, restrictions. Now science is restricted to laboratory benches, and technology is restricted to industries. Here industries applied, when science is applied in the form of industries, it becomes technology. For example, industrial revolution. Industrial revolution was initiated by discovery of steam engine, that is study of heat and thermodynamics. Number 2, wireless communication system. Wireless communication was initiated by discovery of electromagnetic waves, and today we have radio, TV, radars, mobile phones, etc. Number 3, electricity generation. We have hydrothermal, nuclear, tidal and geothermal plants to generate electricity. And number 4, illumination industry, in which electrical energy is converted into light energy in incandescent bulb, sodium lamp, tube lights and light emitting diodes. Number 5, weather forecasting and geographical surveys. Remote sensing satellites and geostationary satellites are launched into space. So this is all technology. Then on medical side, medical application, number 6, medical applications, infrared heating to relieve from muscular pains, shortwave diathermy to cure joints, displacements, x-rays to identify fractures in bones, etc., etc., are all technology, part of technology. So what is science? Science is restricted to laboratory benches for doing experiments and formulating theories, but technology is the application part of science. Okay. Now basic forces in nature. What are the basic forces in nature? There are 4 basic forces in nature. First is gravitational force, second is electromagnetic force, third is strong force, and fourth is weak force. Now let us take up one by one. First we take up gravitational force. The force of attraction between any two bodies of the universe is defined as gravitational force. This force of attraction is directly proportional to the product of their mass and inversely proportional to square of distance between them, and is along the line joining their centers. It constitutes the statement of Newton's universal law of gravitation. For example, planets go round the sun, stars formed, galaxies are born. The structure and evolution of the whole universe is governed by gravitation. So is the gravitational forces. Is weak force as compared to electrostatic force of the order of 10 raised to power minus 36 to the 10 raised to power minus 39 newtons. Okay. So as compared to electrostatic force. Now we come to electromagnetic force. It is a joint venture of electrostatic and magnetic force. Electromagnetic force is equal to electric force plus magnetic force, you can say. Though electric and magnetic forces and their effects are a different phenomenon, but they are closely interrelated through electromagnetic force. For example, electric charge moving in magnetic field experiences a force Fm equal to Q V cross B. Q V vector cross B vector. It's a cross product of velocity and magnetic field. So Fm is equal to Q into V cross B. Second, moving charge produces magnetic field. Third, oscillating charge radiates electromagnetic waves. Okay, now we come to nuclear force. The force that binds nucleons together in the nucleus against electrostatic repulsion between protons. This force is attractive in nature, strong force, short range force, and exists between pairs, proton-proton pair, neutron-neutron pair, and proton-neutron pair. So it has four characteristics. Nuclear force, it is attractive in nature, strong force, short range force which operates between 2 to 3 Fermi from center of nucleus, and exists between pairs, proton-proton, neutron-neutron, and proton-neutron pairs. Now we come to weak force. Now we talk of weak force. This force is associated with nuclear interactions but is not very well understood. This force has magnitude about 10 raised to power minus 15 Newton. Here you can note it. For example, in beta decay, one neutron decays into a proton, an electron, and antineutrino. That is, one N0 decays into one P1 plus E plus antineutrino. Nu with a bar on it becomes antineutrino. Now how it happens actually? Neutron is consisting of up-down-down quark, and proton is consisting of up-up-down quark. Now one down quark of neutron is converted into up quark, and the difference in the mass is generated in the form of beta particle, that is an electron. Now electron and antineutrino interact exclusively through the force which is called as weak force. Its magnitude is 10 raised to power minus 13 times that of electrostatic force, and that is equal to 10 raised to power minus 15 Newton. Now we come to nature of physical laws. So what is the nature of physical laws? Let us see. Now what are the physical laws before us today? We have law of conservation of energy, we have law of conservation of linear momentum, we have law of conservation of angular momentum, and law of conservation of charge. These are physical laws, and their nature is they are conservative nature. So nature of physical laws, we can say energy, momentum, and charge remains conserved in an isolated system. Okay, so what is the nature of physical laws? Energy, momentum, and charge remains conserved in an isolated system. So conservative nature, they possess conservative nature. Now scope of physics. Scope of physics ranges from space, time, matter, motion, energy, and radiation. So these are the 6 worlds which are associated with physics, and we are to understand the nature and natural physical phenomena happening in space, and this is the field of physics. Now we come to assignment number 1. Continuing with assignment number 1, question number 29. What is physics and its scope? Question number 30. Differentiate between unification and reductionism. Question number 31. Differentiate between science and technology. Question number 32. What are basic forces in nature? Explain each briefly. Question number 33. What is nature of physical laws? So you answer these questions on the basis of information gathered in this topic, and then we come to end of the first chapter, that is physical world. Next time we'll take up second chapter of this textbook, that is units and measurements. Thank you so much. God bless you.